Okay, so today we're going to talk about similarity criteria for our Unit 7 with the dilations. We're going to start talking about the vocab with corresponding versus proportional lengths. Okay, so corresponding means that they're angles or they could be sides that are in the same spot, but in a different shape. So it's basically saying they match, right? And now we also are going to work with the idea of proportional lengths. Okay, so when we're talking about that, we're talking about lengths that can be set up as two fractions. And those fractions are going to be equal to one another. Okay, so when I say that, I'm talking about like if we put side A over a side B, it'll match to side C over side D. So we're talking about sides, we're not talking about the angles here. Okay, remember, if we're talking about angles, one of the primary properties of a dilation is that the angles remain the same. Okay, all right, so we're going to add in that, okay, we saw in the last lesson that if two triangles are similar, then the corresponding angles have an equal measure, but the corresponding pairs of side, they're only proportional. Okay, why does that happen? Because if we have a small triangle compared to a big triangle, yes, the angles will be equal, but the side lengths, this side is nowhere near the same measure as this side length here. Okay, so moving further along. There's three major criteria that we're going to use to prove the triangles are congruent. We're also going to use them to prove of them for similarities. Okay, now remember we talked about similarity transformations. Could be a dilation alone or a dilation in either a translation or with a rotation or with a reflection. Okay. All right, so we're looking at these notes here, and we're going from triangle ABC up to triangle DEF. Right? In order to do that, we need to be able to calculate the side measures. So 4 centimeters versus 5.5 centimeters. Okay, so as we're doing that, we're going to actually determine, in order to give a dilation, they're talking about the idea of a scale factor. Okay, what does that mean? Well, I need to figure out how I'm going to get from the small to the big. And how I do that is by figuring out the K. So now remember, a scale factor means to multiply the image, pre-image, by a number to get to the image. So 4 is my pre-image, multiplied by some number. Remember, scale factor is also known as K. And it should get me to 5.5. Okay, so to figure out the K, all we do is divide by 4. It's a one-step equation. So we get K equals 1.375. All right, moving on to the next. Okay, so they just asked us about this question yesterday. We can see these angle marks in here. Angle A maps to angle D, and angle B maps to angle E. So it asked you, would this dilation change the measure of angle A or the measure of angle B? Well, if we look, nope, it did not. Why? Dilations preserve angle measures, which means keep them the same. Okay. Now today for this lesson, I crossed off this question here. I did not quite like it. All right, so we did in Unit 3, we talked about how to write proof. So S stands for statement, R stands for reason. Okay, so if you remember write-in proofs in Unit 3, you would always start off with, and I hope you remember this, the given. Which if I go back up here, here are the two givens that they give us, and how do I know that? Because they said given. Okay. So I'm given angle A is congruent to angle D, and angle B is congruent to angle E. So therefore, this is a given. So if we're looking at these two triangles, what I'm trying to get you guys to understand is that these are only similar, meaning they share some things but not everything, such as the side lengths. So one of the ways to prove that triangles are similar, triangle ABC is similar to triangle DEF. Why is that? Because we have an angle and an angle in equal measure. And that's it. That's all that one is. All right, moving on to exercise 2. Right, in exercise 2, they want us to prove that these two triangles, MQR, is similar to MNP. Okay, small versus big. What I'm going to do to start us off is I'm going to actually write these angles in here. Okay, so angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Right? So I'm going to use that theory that I was just talking about, angle, to help me prove that these two triangles are similar. Okay, so again, the first thing we always start off with is a statement and a reason. Our first statement, always the given. This is what they gave us. This is what they're asking us to prove. I cannot use the proof to help me get there. It should be the last statement. So QR is going to be parallel. Remember, that's the symbol for parallel. NP. Why? That's a given. Okay. All right, next. Next, I'm going to prove a couple angles are congruent. Okay. And also mark this one up here. This is angle 5. Okay. So, one of the things that I'm going to point out, angle 5 is congruent to angle 5. Now, we studied one of these properties way back in Unit 3. We can state that angle 5 is congruent to angle 5 because it's the reflexive property. It's its own angle. It's a piece of both that little triangle and it's a piece of the big triangle. They have that same angle in common. Okay, so I can do that. 3. I'm going to write that angle 1 is congruent to angle 2. Now you'd have to think to yourself, why is that congruent? Right. Way back up at the top of your paper, we covered a very specific vocabulary word, which is corresponding. Corresponding angles, that's what this one is, an angle, is in the same spot, but it's on a different shape. Okay. So if we look at these two triangles, this is the bottom left-hand corner of the small triangle, and this is the bottom left-hand corner of the big triangle. That's what corresponding looks like. So that's corresponding. Now we could have also used the idea that angle 3 is congruent to angle 4 for that same reasoning. They're corresponding angles. Okay. So that new theory that we were working on is that if we just have two angles in a triangle, it doesn't matter which ones. Like the 2 from this triangle will need to match the 2 from the bigger triangle. So therefore, now we have enough information to prove that they're similar. So we would just state that as angle. Okay, exercise 3. When we're looking at exercise 3, we need to understand what they gave us. So in the above diagram, MQ is 8. NQ, that's just from here to here, is 6, and n to p is 21. What is the length of QR? Here's QR. I'm going to call this x. Well, I can see one piece of corresponding sides right away. This NP matches this QR. So I'm going to set this up as big over small. It's matching pieces. So I'm going to set this up as 21 over x is going to equal, now remember this is that proportion, the lengths are proportional. Now the big, this 6 right here was not your big. I need this whole entire side. Well, I know this piece is 8 and this piece is 6. So then the big piece is 14. So the length of the big triangle is 14 over the length of the smaller triangle of 8. Okay, from here you cross multiply. 14 times x is 14x, and 8 times 21 is 168. And just like we did when we were figuring out the scale factor, we just divide. And we came up with x equals 12, which is the length of QR like they asked. If you need to, you can always rewind at this point and rewatch it again just in case you're still confused. I'm going to flip over to the back. Okay. So for the top part of this page, they want us to give a dilation with its center and its scale factor. That would map from ABC, I'm going to cross out this part right here, onto triangle DEF. Okay. So the center in this one, I'm just going to call it A. Okay, the length from A to C is going to double for D to F. And we'll just leave the center at A for both of them. The more important thing that I want you to understand is the idea of the scale factor. Okay, so that means just looking at, like, here's the side AC, 3, and I need to get up to 6. Well, that scale factor should be easy. That's times 2. And it follows for every single one of them. 4 times 2 is 8, 5 times 2 is 10, so the scale factor for here is 2. Okay. The theorem, though, that I need to prove that would map onto this, so I need a congruence theorem. Triangle ABC would be similar to triangle DEF. How do I know that? Side, side, side. Side, side, side. All the sides were multiplied by 2, so the theorem would be side, side, side. But it's not that they're equal, it's that the sides are similar because they were all multiplied by a scale factor of 2. Now if I do B, the scale factor isn't as nice. You can't figure out 10 times what is 15? I don't know. 14 times 21? I don't know that one either. So I have to set up an equation in order to help me. 10 times what is 15? Well, that's the scale factor, k. So 10 times k should equal 15. So then I divide by 10 on both sides. I get k equals 1.5. Now if I'm looking here, I can see that the two triangles are going to be similar by a side first, then an angle, and then a side. So the theorem here is side, angle, side, meaning that the sides are proportional, being multiplied by the scale factor, but the angles are equal. Remember, dilations preserve the angle measure. Okay, so just a quick fill in the blank. For the angle criteria, it's 2 angles of one triangle are congruent, meaning that they're equal in measure, to 2 angles of another triangle. The 2 triangles are similar. Okay. The side, side, side criteria. if all three pairs of corresponding, which means matching, sides of two triangles they're not congruent. Remember, we use the word proportional because they are multiplied by a scale factor. Then again, the two triangles would be similar. And for the side, angle, side criteria, we would need a side, an angle, and a side. But remember, the angle has to be in between where the sides connect at. It's got to be in between. I can't use the angle that's up here. It has to be in between the two sides. And that's what they're going to explain down here. Okay. The side, angle, side criteria for similarity is if two pairs of sides of two triangles are, remember, sides are proportional. And the angles included, remember we're talking about angles now, between those two sides are equal. Then that is when we would get that the two triangles are similar again. Okay, so exercise number 5 matches one of your questions in the homework. In the diagram below, which one would be not sufficient, which means I can't use it. So pretty much most of these look like they are going to be used. Like this looks like side, side, side. This looks like side, side, and then an angle, which could be side, angle, side. This looks like maybe it could be the angle, angle theorem. And this also looks like that side, side, angle theorem. Okay, so let's check to make sure that this is proportional. RS matches with AB, that's correct. Okay. ST with BC. That might not be it, but let's take a look. BC matches with, yep, it does. With ST, they're in the correct position. Okay, so this looks like maybe it was a reflection and flipped it to try to trick you. Okay, and then TR, T to R, should match with A to C. And yep, it does. So that's a check. Those are all proportional. So let's look here. Now these ones are the tricky ones. Okay, so I'm going to save 2 for a second and come back. Does S match with B? Well, let's check. S is in the second position. B is in the second position. Yes, it does match. Let's check here. Does C in the third position match with T in the third position? Yep, that angle theorem does check out. Sorry, that's AA. That one checks out, so it can't be those two. This one was side, side, side. So now it's down between these two. Okay, so let's check for number 2. AB, does that match with RS? AB, RS. Yep, they're talking about this side here and this side here. Does A to C match with R to T? Yep, it does. A to C match with R to T. Yep. Now remember, they're not really congruent, so I'm not really trying to make tick marks on them to show congruency. I'm just showing that those sides are the sides that go together. Let's take this angle A. Yep, it matches to angle R. They're both in the first position. Now you have to ask yourself, is this angle in between these two sides? Yes, it is. So this is the side angle side theorem. Even though they didn't give it to us in that order, this is the order of it. Can't be that one. So let's check this one right quick. I'm going to do this one in a different color. Okay. Angle B does match with angle S. TS does match with CB. And RT does match with AC. But what you will notice is that the angle is not between the two sides. That would be down here. So what we're looking at is that naughty word. Angle, side, side. This is the angle, side, side theorem. So this one, that's a big no-no. Don't use that one. This one is not enough information to prove it. The real answer here is choice 4. Okay, so if you have any further questions, please see me after school to elaborate.